Good afternoon and welcome to this afternoon's webinar, Connecticut's Computer Science Course Reporting Guidance. During today's webinar, you will learn about the background of why this guidance has been created and how you and your districts can use this to ensure that the courses you report to the state of Connecticut in terms of computer science are accurate. On today's webinar, we have a team of people who have worked on this project from its inception. Susan Auchincloss from Ready CT, Danielle Bousquet, who works out of the Performance Office at the State Department of Education. Unfortunately, Jackie Coricelli, who is the Connecticut Computer Science Teachers Association President, and Seth Freeman, a professor at Capital Community College, are unable to be with us today. I'm Jen Michalak. I'm the Math and Computer Science Consultant out of the Academic Office at the State Department. And last but certainly not least, we have Dr. Chinma Uche joining us. Most of you know that Chinma has been a pioneer for computer science education in Connecticut. This project has been funded from the Expanding Computing Educational Pathways. In order to support this project, we would like to make sure that we thank the school districts who assisted in us gathering our data and the development of the guide. They are Bridgeport, Crack, New Haven, New London, and Newtown. At this time, I will turn it over to Susan, who will provide some background on the guide.
Thank you, Jen. So many of you are probably wondering, why do we even need a new computer science course code guide? And there's a few reasons for that. One is that, it's always good practice to have good data. Another one is that in 2020, the state of Connecticut adopted a computer science plan. And as part of that plan, we need to have metrics to measure our progress. And then third, it's very important to measure the effectiveness of the initiatives that are going to be enacted as we enact the state computer science plan, because we want to expand capacity, access, participation to all of the students in Connecticut, as well as underrepresented students, minorities, and girls. Next slide, please. Great. The process that we went through when we developed the guide was we utilized the current data systems that we have already at the state, which are great. We partnered with the variety of school districts that you saw listed on the first slide that Jen went over. We used input from the New England Metrics Project to help us form the guide. And just so you know, this is not a standalone project that just Connecticut is doing. This is a nationwide movement. There are many other states that are involved with this type of projects, and this particular team is involved in the New England Metrics Project. And we obtained feedback from the districts who had, advance notice of the guide. Next slide, please. So the impact that we're hoping to achieve when we roll out this new guide is that we really want to understand the challenges and barriers that there are out there when reporting computer science courses. We want to engage with districts on their reporting expectations. We want to provide an awareness of broadening participation in computer science classes and create an awareness on the part of the districts. And by the end of this webinar today, we are planning that you're going to have a good understanding of what elements constitute a computer science course and how to code them. Next slide. So I referenced a few times the computer science state plan. And just to give you a bird's eye view of some of the elements that went into that plan, I feel it's important to give you. We started with a current landscape and strategic goals. A large goal is to diversify our offerings in computer science as well as participation. It's very important that we have diversity measured as part of the rollout of the K-12 computer science plan. We need to expand the teacher pipeline. We need to understand curriculum and courses as they relate to standards and graduation requirements. There will need to be a fair amount of outreach to students, to teachers, to school districts, to the community. And another part of the computer science plan is we need to figure out how to fund it. Next slide. Thank you. So goals that we're hoping we're going to achieve by the end of this session is to provide a common understanding of computer science, to promote the accurate computer science course reporting. That will enable us to measure the impact of our computer science initiatives and to identify trends in computer science education in our state in grades K through 12. I think now I'll hand it back over to Jen.
One of the questions that is often asked of the State Department is what type of teaching endorsement is required in order to teach computer science. Currently, regulations say that as long as you are grade appropriately certified, you may teach a computer science course. What does that mean? Well, for instance, my endorsement is Math 712. That means that I am able to teach math and/or now computer science in grades 7 through 12. If someone is certified elementary grades 1 through 6, they would be permitted or authorized to teach computer science in any grade 1 through 6. However, we know that being authorized to teach a course doesn't always equate with having the content knowledge to be able to effectively provide instruction. So as a means for districts to work towards ensuring that they have the most qualified individuals, we have developed a computer science cross endorsement. This endorsement is only available to currently certified teachers and currently provides 2 options to obtain. The first is the most traditional coursework option, in which you either have a major or 30 semester hours of credit in a content related to computer science. Related to would include most of our sciences, mathematics, some of our technology education. There's a wide range that could be constituted as related. Ultimately, that decision is made by the certification office upon transcript review. Within your coursework, there needs to be a minimum of 12 semester hours specific to computer science that touches upon the area of computing systems, networks and the internet, data and analysis, algorithms and programming, and impacts of computing. For many people, this course-specific endorsement can be overwhelming and cost prohibitive. We know we're in need of expanding access to computer science, and expanding access means ensuring we have the teachers capable of doing this. So recently, the State Board of Education has adopted the Subject Area Assessment Test, Praxis 2, and has enabled a qualifying score of 149 to allow for currently certified teachers to obtain cross endorsement without the added coursework option. This guideline follows similarly to our shortage area endorsements. Certainly, if there are more questions on how to get endorsed in computer science, we ask you to put your questions in the question box, save them for the end, or contact me directly. As we mentioned, as long as you are certified grade appropriately, you may in fact teach computer science at that grade appropriate level. This would mean someone who is certified, let's say in the arts, K-12, could in fact teach computer science at any level K-12. That would not be considered teaching out of their area of authorization. Many teachers fear that if they do, it will impact their teacher retirement. However, your certification authorizes that as a course you are authorized to teach, and therefore will not impact your retirement program. That being said, many people across our state believe that credit is determined by the certification that the teacher holds. This is a myth. The credit is determined by your local Board of Education based upon the content of the course, including, and most importantly, its alignment to standards. Therefore, if a course is aligned to NGSS, your local Board of Education can say that that course provides a science credit. The teacher certification only says who is allowed to teach that course under current regulations. What makes this important in the area of computer science as we continue to expand access is that the class of 2023 requires 9 credits in STEM: science, technology, engineering, and math. That opens the door for computer science to count as one of the core credits for the class of 2023 and beyond. The decision whether computer science will be allowed to fulfill that 9 credit requirement is left up to each individual local Board of Education. At this point, I will be turning it over to Danielle, who knows more about the performance end of course reporting.
Hi, everyone. So I know what you're thinking. So you want us to report computer science classes, now you're going to have a whole bunch of extra work, right? That's not what we're intending to do. Our intention is to have this work with the existing teacher course student data collection, which happens every year toward, after summer school is over. So the guide that we've created is updated for versions 7.0 or 8.0, depending on which one your school is using. So this goes right along with that same transition. What's important to know is that courses will only be counted as computer science if they appear in this guide. So this guide will provide you basically a list of all the courses that are included. And we don't have someone that will sit there and say, well, okay, this might be okay if you send us a syllabus. It doesn't work like that. This is the list. If you need more help with TCS, please visit the help site. I'm going to give a very fast overview of what is going to be included with TCS reporting. So the guide is going to provide you assistance just with selecting that initial 5-digit codes, either called SCED code and NCES code, depending on who you ask. It doesn't have any information about the rest of the NCES full course code. So we're going to talk about it just really fast. Next slide. So the first thing to note is those first two numbers, the subject area code, that is not dependent, that does not determine what's in the guide. So there are computer science courses, a lot of them fall under the information technology subject area, which is number 10. But not all of the computer science courses are in subject area 10, and not all of the courses in subject area 10 are in the computer science guide. So you want to make sure that you're not only depending on that, on the subject area to determine what's a computer science course. So a computer science course can occur at any rigor level, so long as the description applies. So it could, you can have basic computer science courses, general, enriched, advanced, honors, or college level. The idea is that you want to make sure that whatever the course description is, it matches the level that you have. But if there's no other course description that matches and you want to make it a more basic or a more advanced class, the course rigor level is one way to do that. The computer science courses do not have a minimum credit requirement to count as a computer science class. So if you have a 0.25 credit class, that will count as a computer science class. I want to mention really quick that if you're using these courses, because a lot of them overlap with career and technical education courses, which get used for Indicator 5 on the Next Gen Accountability, they will not count as a CTE course unless it has at least half a credit, so 0.5 credits. So just make sure that if you're using it for both purposes, that you aren't getting held back there. So the sequence you want to use if you have two courses that are intended to be taken one right after the other. So, Java 1, Java 2, things like that. Always make sure you check and see if there isn't a more appropriate code for that second course. For instance, and this is not computer science, but Algebra 1 and Algebra 2 have different codes, even though they're intended to be taken one after the other. So, but if you have two courses that really don't fit anywhere else, and one is supposed to be taken after the other, go ahead and use that sequence. I'm just going to warn you, if you have a student who, for whatever reason, is taking those two courses at the same time, they will not register as different courses. So make sure that they really are intended to be one after the other. So some quick examples here. Java programming, which is SCED code 10155. So if you had Java versus advanced Java, right? If the advanced Java course is intended as a prerequisite, if the Java course is intended as a prerequisite for advanced Java, use the course sequence. Oh, and my boxes got, not sure what happened to the boxes. But the idea is that your advanced Java course, you can see, has the last two digits are 1 of 2, and the advanced Java is 2 of 2. So use the course sequence. On the other hand, if the courses cover most of the same material, but one is intended for more advanced students, then you're still going to use that 1 of 1 instead of 1 of 2 or 2 of 2, and now you use the rigor code to differentiate it. So the regular Java would be G for general. Advanced Java might be E for enriched, or if you have a very specific honors program, then you would want to use H. You don't want to use them for, you don't want to use the honors if there isn't a specific honors program associated with it. So I just want to show why why some of this is so important. So when we look at the 1920, I forget what year we're in, courses in computer programming, what you see is that the very first course, the most prevalent course we see is just computer programming. We don't have any idea what that means. Is that, what language is it? It's a very generic course code. And then you see not that much further down is computer programming other, which again doesn't give us a whole lot of information. So our goal here is to try and find the best courses so that we have the most detailed information. I always say we don't want to have other to be the most prevalent category. The only exception I would point out here is computer programming other language. So we have things like computer programming for various languages. If you don't see the language there and that's what applies the most, that's use other language. That's not intended to be a super generic course code, that's fine. So for some further examples, I'm going to hand it over to Chinma.
Hello, I'll be talking about how the courses are organized in the course code. The courses are organized in two groups, the computer science courses. And the courses are organized in this way based on how they are aligned with the Computer Science Teachers Association standards. Group one courses are those that are aligned strictly to the CSTA standards, and it would be difficult to teach such courses without them being aligned to the CSTA standards. On the other hand, group two courses are courses that may have things in common with the CSTA standard, but are not strictly aligned. They may interface with the CSTA standards and other courses. So they have elements of computer science in them, but they are not strictly aligned to computer science standard. And those will be group two courses. And we will go ahead and give some examples about how these courses relate to each other, how you would see them. And we are hoping that you're going to work from what you already have in your course descriptions and other areas. So group one, alignment to CSTA standards. You may not know the CSTA standards. Your teachers who are teaching these courses would know the CSTA standards. Group two may align with CSTA standards, but may have other things they align more to. So we hope by using a few examples, we'll show you how such matches can be made. Yeah, for example, so we're going to go through 4 examples. The first example we have, what you see on my left-hand side, on the left-hand side is the AP Computer Science Principles. The document we have on the writing there is from a school district's course description. They define AP Computer Science Principles as a course that introduces students to the central ideas of computer science, fostering computational thinking and inviting students to understand how computing changes the world. They go further to describe other key elements of AP Computer Science Principles, such as the development of computational artifacts, and also that it includes core computer science topics such as creative thinking, abstraction, data, algorithms, programming, the internet, and societal impact. When we saw this in a school district's description, we looked at our course scape code, and there you would see that it aligns to our 10019 AP Computer Science Principle. It's easy to match these two together or pair them together because AP is actually a trademark of the College Board. You can't just use AP Computer Science Principles or any course. So when you look at what we have in the scape code and what the school district has, they match, align with each other. So the same name, the fundamental concepts that are being taught, which we have actually used color-coded to highlight. So it's easy now to match this to the appropriate escape code 10019. We'll look at three other examples. The next example is what that school district labeled Honors Python. Python is a computer programming language. So they said, this course is designed to develop structured programming skills in Python. Learning to program offers the student an invaluable opportunity to develop problem-solving skills. They go further to write out what this course does. And based on that, we aligned it with escape code 10156. And if you look at that escape code, it talks about other programming languages. So it actually mentions Python in particular, and also talks about the emphasis. While the school district says it teaches to exercise in learning to think logically, it talks about problem-solving techniques. So they actually align closely with each other. So that's a way, if you have your school district's course description and you have the escape code, you can find the intersection of where they align and match appropriately. So that when we now evaluate the courses or have the data, it can be your district can be appropriately represented. Our third example comes from computer technology hardware. Now, in this particular district's description, they write that in this hands-on course, students build and repair computers utilizing modern concepts in PC architecture. Students will research, design, implement computer and networking systems, learning the latest PC hardware and software technologies. And this actually aligns with what we coded as escape code 10254, IT Essentials, PC hardware and software. Even though the titles are not the same, but the course description and what they teach is actually the same, and therefore we are coding it up with 10254. If you look at the escape code, it says IT Essentials means dealing with PC hardware and software courses that provide students with in-depth exposure to computer hardware and operating systems. It also teaches, as highlighted in red, troubleshoot hardware and PC software problems, and that's on 10254. So looking at what you already have as your course description and looking at the escape code you're receiving today, you can find the appropriate code so that the appropriate data is being collected. Finally, we have a fourth example, and that fourth example is titled in that district's web description, web design. And web design here, it says, with the ever-increasing influence of the internet, students need to prepare themselves for a web-based future. Through this course, students learn how to design, create, and manipulate websites for personal and professional applications. In addition, the basic HTML code, this course will include design and management of this. They go into specific tool they're using, Dreamweaver. But what we're more interested in is what are the core concepts that the students are being taught. And it's design websites, design and maintain websites. So if that's the case, then it's matched to 10201. So we have taken time to List all the scope codes that would align with computer science in one way, either directly those that match with the CSTS standard or those that are matched to related tools, so that we can capture all the computer science that's been taught in the state. Thank you. I'll hand back to Jennifer and others.
So we hope that this brief presentation gives you an idea of the courses that you're teaching in your district and how you can utilize this guide to align them to know if in fact your district is teaching courses that the state of Connecticut views as computer science. In this way, Connecticut is hoping that the data we receive from districts is more accurate so that all of the efforts to expand and broaden participation and access in computer science education can be measured over the course of several years. At this time, we'll take any questions.
Jen, did you want me to read you the questions that are, there's two of them that are.
If you could, I just saw where I had access to that. I apologize.
No problem. Has the policy of cross-endorsing CTE/CS information technology teachers changed?
So that's a great question, and none of us from the State Department on the call today are from the certification office. However, my last understanding is that if you are certified as a CTE teacher with the vocational endorsement, that is a special endorsement that does not qualify for cross endorsement. However, feel free to email me and I can forward that on to the certification, but there has been no recent updates about in regards to that. It is in discussion and how best to address our CTE teachers who are also teaching CS courses. Fortunately, the regulations provide that they can still teach those courses, but right now they're not eligible for that cross endorsement.
Thanks. There's another question. Computer science has no minimum credit requirement, but you said it overlapped with another subject on indicator 5. What was the subject it overlapped with?
Yeah, so it's not a specific subject area. What I'm talking about is for indicator 5 of the next generation accountability system, which is college and career readiness through course taking. So a school can have their students qualify, pass is the wrong word, but meet the requirements for indicator 5 either by taking 2 AP, IB, or dual enrollment courses, or 2 workplace experience courses, or 2 courses from the same career and technical education cluster. So courses in the guide that are computer science courses, almost all of them are also career and technical education courses. So if you want to make sure that the course you're offering is also going to help students meet the requirements for indicator 5, then that class has to be at least 0.5 credits. Does that help explain? It makes sense to me because I do it all day, but I want to make sure that it makes sense to everyone else.
If anyone has any additional questions, you can type them into the question box. We can give it a few more minutes. Daniel, I wanted, or Jen, I did write in the chat that this session is being recorded and it will be posted to the State Department of Education website, but maybe you can let people know where to find it on the website after it's posted.
Sure. So once it's posted, what our plan is this will be posted on the computer science webpage, probably right below the guide that's available on the website. And it may also be posted on the TCS site. I don't know what the official name is for that, where we have guidance for the TCS help area. And I'm going to put my email in the chat. So if anyone needs to reach out to me directly with any follow-up questions, I am certainly willing and able to either answer your question or find the most appropriate person to answer your question.
Yeah, and I'll put mine as well. So if you have any questions about SCED codes or anything like that, that Corinne, I believe we have Corinne with us. She does our TCS collection. But if you have any questions about the codes themselves, just let me know. Corinne just, thank you, Corinne. Just posted a link for where the webinar will be posted on the TCS help site. It's in the.
Excellent.
Okay, well, that's all the questions that we have. And I did put the website into the chat for everyone to access. So you can take a look, give it a few days before we post this presentation. Thank you to our presenters for this webinar, and also thank you for attending. I hope everyone has a nice rest of the day.
Thank
Thank you, everyone.
Thanks,
Thank
everyone.
you.